Okay, we're going to find cube roots. Now, this is a high-level topic, complex numbers, because there are actually 3 roots to z cubed. And one of them is real, and one of them we can do almost straight away. Let's just write that one down. If we cube root both sides, we get 2. But that's only one of the roots. The other 2 roots are going to be complex numbers. And as they always come in pairs, they're going to be conjugates of each other. Now, to solve this, what I want to do is, first of all, use an Argand diagram. So I'm going to put z cubed onto an Argand diagram. Z cubed equals 8, which means we go along here 8 units. And remember that this is the real part, this is the imaginary part. So that's 8 units long, and that's z cubed. So armed with that, I can write z cubed equals 8 CIS, cosine I sine, 0. Now that's the first step. I've written it in CIS form. So the real part, the modulus, and the argument. Next, there's actually I want to think about there being infinite solutions to that, which is to write that as 0 degrees plus 2 pi k, where k is an integer. So all that's saying is that I can have 0, I can have 2 pi, I can have 4 pi. So that's that whole thing being rewritten just with the argument always going around circular. Now we're almost there, because the next thing we're going to do is we're going to take a cube root of both sides. And when I take a cube root of both sides, it's going to be 8 to the power of a third. And this number inside the CIS, the argument number in here, so CIS, 0 plus 2 pi k, that can all be written over 3, because I can divide it by 3. And the reason I can do that is because of the things that we've learned with de Moivre's theorem. And now I'm ready to start working out all the different cube roots. So I'm going to start off by making k 0. We've kind of already done that. If I make it 0, we get 0 over 3. We've got 2 CIS 0. That's the one we had at the beginning, z equals 2. Now I'm going to make k equal to 1. And this will work so long as you use 3 consecutive numbers. So I could have chosen 1, 2, 3. I could have chosen 0, 1, 2. I could have chosen 99, 100, and 101. It'll always give me 3 consecutive roots. So this becomes 2 pi times 1 over 3. So this is going to give me 2, because I cube root that. And then the CIS number, the argument, is 2 pi over 3. And finally, if I make it 2, it's going to give me 4 pi over 3. And there's beautiful symmetry in these numbers, which I'm going to show you about. This is the conjugate of this, and I'll show you why using another Argand diagram. So let's just flick onto the next page. So here are my 3 roots, and I'm going to redraw them on another Argand diagram. So again, I've got real and imaginary. Now the first one was z equals 2. So let's just take this one. Z equals 2. Nice straight line. Z equals 2. So it's just going to go along there 2 units. The second one was Z1 equal to 2 pi over 3. So 2 pi over 3 is going to come in the second quadrant. And that angle in there is 2 pi over 3. And then it was 4 pi over 3. So it's going to come down here like this. And here's the great thing. This is a conjugate of this. You can see clearly now that one's a conjugate of the other. It's just the same real number, but the imaginary number is negative. This angle in here, 2 pi. This angle all the way around there, 4 pi. So what's this angle here? 2 pi. Sorry, 2 pi over 3. 2 pi over 3. And what's this angle in here? 2 pi over 3. So we've got this beautiful symmetry when we draw it on an Argand diagram as well.